Okay, now that we have this model, let's put some toolpaths on here and start cutting. So first thing I'm going to do is switch to the manufacturing area. I've already got this set up with some toolpaths, but I'll slowly walk you through each one of them so that we can understand what I'm doing with each one of these. So the first thing we'll do is we'll take a look at the setup. In this case, I just have a stock that I've defined, 8 inches by 5.5 by 0.75. I've defined my X, Y, and Z in this corner here. For this particular job, I might want to reposition it in the middle here, and I'll explain that in a minute why I'm going to do that. So here we'll just choose box point and we'll select it. Now, for some reason your X, Y, and Z aren't in the right orientation, you can always correct that. So for example, I can choose this option here to select my Z-axis and the X-axis. All I have to do is pick some geometry, or I can pick the actual information in the origin as well. So this looks correct, from my stock setup. Since I'm not going to be facing the top of this, I've got it set exactly to the height of my board. Now, once I measure my actual stock, I might adjust this accordingly to match the physical piece of wood that I'm going to be cutting. Let's take a look at my tool library. Remember early on in an earlier lesson, we looked at some preferences here. And under manufacturing, we had enable cloud libraries turned on. And so if we look at my tool library, you'll see that I have this cloud option now available, and then I have Shapeoko tools listed under here. Now what I've done as well is I've created a tool for my collet, or not my collet, but the holder of my Makita router. This is important because by using this, I can also detect any kind of potential interferences or clashes while it's running. Here you can see I have lots of different tools ranging from 16th inch ball to square, tapered, flat, long reach, chamfer, and V-carving type tools. My flat wasteboard facing tool, 1 inch. I found a 1/2 inch ball end nose or ball nose that I use, and I have a flat 1/2 inch end mill that I use for large clearing with adaptive. I also, if you look in here, I'll just open one of these up. I've also set the speeds and feeds that I most commonly use with these tools, so I don't have to keep changing them. So here I have 21,000 RPM, 75 inches per minute. These are probably pretty conservative by most people's standards, but they've been working out for me. Obviously, the harder the wood, you might adjust these, or the softer the wood, you might adjust these as well. Here you can see that I've defined all the information that I need, for this. So I have my shafts, my holder that I use, and again, I can't stress that enough. It's pretty important to have that in there as well. So if you don't know about adaptive, I highly recommend using adaptive for clearing out large areas of material. It's a very efficient toolpath. It does a great job, and it's really good for initial roughing operations. So if we edit this, we have some choices. Here, of course, is the RPMs, the tool that was selected, the feed rate, the geometry. In this case, it's automatically selected the stock contours, the heights. In this case, I'm not going to be cutting through all the way to the bottom to my final contour. So I can see here that I might want to adjust that. and I'm going to pull that up 0.1. Passes. I have a pretty aggressive step down here, which engages a lot of the tool, 0.39. This was put in by default when I selected that tool, so I didn't mess with that. And stock to leave, I usually leave a decent amount of stock just to accommodate for, wood tearing, abnormalities, that you typically find in wood that I can easily clean up, with a finishing pass. The two options that I look at here on this linking tab are the type of entry. For softer woods, I can do a plunge, which will plunge right into the part. But for other types of woods, I'll do a helical entry into this. And so here we can let it generate and see what that first toolpath looks like. The other option that I told you to turn on in the preferences area was to display the time for each operation. So you can see next to these, it's got 2 minutes, 9 seconds, 2:39, 28, etc. And these are helpful when I'm looking at this because I'll make some adjustments to try to minimize, that amount of time. Next part of this would be the pocket. And so let's just go ahead and generate all these and take a look at how these run. Okay, now that those are generated, I'm just going to simulate the first two of these. So the first operation, we'll just go to the end here. And then for this pocket, all I want to do is remove what's remaining here. Generally, a pocket would try to just cut all this air as well. But in this particular case, it's just going to remove the remaining stock that's inside of that pocket. So how did I do that? So in this case, I again chose my tool, 1/4 inch flat. Here's all my options. I chose my boundary here as well. And I have my containment, tool centered. We can look into these options later as to what they do. And here I chose this rest machining, and so this stands for remaining stock, as you can see here in the quick help. What I'm telling it to do is remove anything that's left over from the previous operations. And so what that's doing is it's eliminating the need for cutting air. If I uncheck this, you'll see the impact that we have on this. We go from 2 minutes 39 seconds to 5 minutes 33 seconds. And you can see all this wasted space here that it's calculating that it really doesn't need to. So if we simulate this and then play the next operation, you can see it's really cutting nothing there. And so that's just wasted time and wasted tool travel. So we'll go back here and we'll turn rest machining back on from previous, and now we have a much cleaner toolpath. This pocket operation really does the same thing. It's just pocketing in and cleaning out these eyes. This slot, this is useful if your tool is the same diameter as the slot it's cutting. So in this case, this distance here is the same distance as the diameter of my tool, and with the smiley face here, that's the same distance as well. What I've done for this example is I've really dialed this down to go really slow on the feed rate. Generally for things like this small, for example, I'll dial it down really slow just to be safe. And then here you can see I'm not leaving any stock because that's a finishing toolpath. And we have circular. So you'll probably use this to cut your wasteboard. Here we have a larger diameter than the tool, and this will just kind of go in here. Again, I've slowed this feed rate down quite a bit. If you're going to be cutting 60 holes or more, you could certainly speed that up, especially with MDF. And then lastly, we have this drilling operation. Now, a lot of people don't tell you that it's not a good idea to drill with a flat end mill, but if you do it slowly with these options, I've had good success. If you're going to do a lot of hole drilling, it's probably wise to invest in a proper tool to do that. So here under cycle, I've chosen the cycle time of deep drilling, and then I have this pecking depth of 0.06. So let's go ahead and simulate all of this now and see what it's going to look like. So there we have it. It's complete and ready to go. Next thing I want to address is how I'm going to hold this part down, on my wasteboard to cut it.